Okay guys, this is two element series circuits, question number 11. This one tends to give some students a little difficulties, mainly because we don't have a jumping off point for it too quickly. They've given us P1 and P2, alright? They've given us an R total, and that's it. So you might think, oh, what do I got to do here? Well, we know that we can find the power total here. We can go 1500 watts plus 500 watts to give us 2000 watts. Okay? Now we can look at coming up with either A, current, or the E total. I would prefer going for current first. So using P and R, how do we solve for the current? So remember, P is equal to I squared R. So if we've got the power and the resistance, we could then convert this into I is equal to the square root of P over R. Alright? Hopefully I've done that correct. So if we went the square root of P over R, so 2000 divided by 60 and then square root that, that'll give me a current in this circuit of 5.77 amps. Okay? And then from there, it's pretty straightforward. We can go 5.77 times the 60 to give us a total voltage of 346.4. Or sorry, yeah, 346.4. All right, and then we can also go 1500 divided by 5.77 to give me my voltage down there of 259.8. And then we can, while we have that number in our calculator, we can go 259.8 divided by the 5.77 again to give us 45 ohms here. Okay. If I know my R total was 60, then that means that R2 must be 15 ohms. How did I get that? 60 subtract 45 gives me 15. Right? We can confirm that by also going 500 divided by the 5.77. That'll give me, pardon me, a voltage there of 86.6. Okay, and 86.6 divided by 5.77 should give me my 15 ohms there again. Okay, we can then add these voltages up, 259.8 plus the 86.6, and it should come really close to that 346.4 volts up there. Now, keep in mind these numbers here, try to get them as accurate as you can. I might have some rounded numbers here. Whenever possible, go to 2 decimal places. It'll keep things more accurate. And the other thing would be, if you know how to use your store and recall function in your calculator, anytime you find the current in a circuit that has a long number, in other words, not 5.77, but something like 5.7685, whatever, okay, store that entire number, because it'll mean that all of these values that we get down here, utilizing that stored current, is going to be far more accurate than pulling a rounded number into all of these and then pulling more roundedness out. So what that'll end up doing is making your numbers either greater or smaller than the actual answers I have on the worksheet. Okay? So hopefully that'll give you a little bit of a hand with question 11 there. All right? I think we'll shut her down now.